Today we'll be looking at lesson 7.3, and the learning goal is I could translate points and reflect them on a coordinate plane. So we're going to be going over two different topics today. One is translating, and one is reflecting. Let's go over some vocabulary before we start today. The first vocabulary is going to be coordinates, which are a set of values that show an exact position. An origin is the starting point. Translation means moving in geometry. We're not rotating, resizing, or anything else, just moving. And the x and y axis is the x line that goes through the graph horizontally. And the y axis is the line on the graph that goes vertically, up and down. I'll show you some examples here where we translate some images. Here's an example of a great translation of some wonderful architecture here. See how the image is the exact same, but it moves? Here are some pictures of some beans that are being translated from one position to another. Alright, before we start, let's look at some jokes. It says, "My time machine is complete. Now to test it to see if it is going forward in time by week." So it says the 5th here. Oh, the time machine fell on him. Excellent, he's coming out of his coma. Ugh, the date, what's the date? It's the 12th. Ah, it works. This is a demotivational poster. It says, "If at first you don't succeed, then skydiving is not for you." And there's somebody skydiving. Okay, so let's take a dot and we're going to go ahead and translate it. So as we mentioned in our previous lessons, the origin is the 0, 0, but in this case our origin is going to be our dot. So the problem says to go translate 9 units up. So up means to go up, so that's what we're going to do. So put your pencil on the N, and we're going to count up 9 spaces. Now remember, when you're counting on a graph, it's important to count the corners. So this isn't 1 here, but this is 1 here. So let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's important to label your letter with a little dash above it like this. There we go. We've translated our point N up 9 spots. Let's do another one. Again, our starting point is going to be the letter E. It says to go 5 units left and 4 units up. So we'll put our pencil on the letter E, and we're going to count 1, 2, 3, 4, 5. And then we'll count up 4 units. 1, 2, 3, 4. We'll put a dot when we went over left and then up 4. Next, I'll label my point with the letter E with a dash above it. This dash above it means that it's different from the original point E. In math, they like to call this prime, like Optimus Prime, except it's a prime letter. So we've done a couple examples now with translations, and we're going to move on to reflections. Can you think of any examples where you've seen reflections in your everyday life? Well, maybe you said a mirror. And that's exactly what the definition of a reflection is. It's a mirror image. Reflections are everywhere, in mirrors, glass, and here in a lake. What do you notice about these two images? Well, maybe you said that the image on the top of the mountain is flipped into the water. Every point is the same distance from the central point. There are some other examples of where we see reflections. So this past winter break, I went to Cologne, Germany, and we went to the Lindt chocolate factory. And if you could see how this image is stretched out and laid out, it's reflected on this coffee mug here. This is a better image of that same thing there. So it's stretched out and then it's reflected back onto the coffee mug. So here's an image of a chocolate mold, and you can see how this is the original image and what it's supposed to look like. and this is the this is the chocolate mold here. Because the chocolate fills in the gaps, when you flip it over to get the mold, if you turn the mold over, it would still be the same image. See? So if you're ever making chocolate, you'll notice that the mold is flipped the other way. That's that way so you can actually get the image the right size. I'll show you one more like that. It's a picture of Lindt himself, Mr. Chocolate Man. There he is. Okay, there's the mold, and there's the supposed actual image. How cool is that? Okay, let's look at some examples of where we reflect some points on a coordinate plane. So as we talked about before, the origin in a lot of examples when we're plotting points is 0, 0. But in this case, we already have a point here, so we're going to reflect that. It says to reflect it over the y-axis. Do you remember which line is the y-axis? If you said the y-axis is this big blue line here, then you were correct. So we'll put our pencil on C, and we're going to count over to the y-axis. 1. Now, from here, we will go one more point. 1. And then we're going to label it C prime. If you remember from our original definition, it says every point is the same distance from the central line. And that's true in this case. Congratulations, you reflected point C. The last example, we reflected a point over the y-axis. And now we're going to go ahead and we're going to reflect the point over the x-axis. Do you remember where the x-axis is?
Yeah.
If you said the x-axis is the line that runs horizontally through the center, then you were correct. Congratulations. So now we're going to put our pencil on the letter B, and we're going to count up from B. Count with me. 1, 2, 3, 4, 5, 6, 7, 8. Now, since every point is the same distance from the central line, we're going to go ahead and count up from there. 1, 2, 3, 4, 5, 6, 7, 8. We'll label it B prime. And halas, congratulations, you've plotted point B. Write the coordinates of the vertices after reflection over the x-axis. So, traditionally, with our last couple examples, we had just single points. And now we're going to actually reflect images. So we're basically going to do what we did before, except we're going to do it 3 times. So you can choose whatever point you want. What a choice. I'm going to choose point B. So because it says to reflect it over the x-axis, this line right here, I'm going to go ahead and count all the way until I get to my x-axis. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, B prime. Next, I'll do the same thing with A. Next, I'll plot point A. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We have one more point to plot. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Next, we'll connect our dots. Do you notice anything different about the original image and the one that was reflected? Feel free to pause the video and think about that for a second. So what did you notice? Did you say that the B that was on top is now on the bottom? And the A that was on the top, on the bottom I mean, is now on the top? That's what I noticed. So our image then is reflected. I have one more example I'd like to go over with you today. And that's reflecting an image over the y-axis. So I'll go ahead and I'll put my pencil right on B here. And I want you to think about what's going to happen to points C and A as we reflect it over the y-axis. So B is 9 points over, and then I'll count 9 this way. And I'll label it B prime. A, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Make sure I have enough room. Count 10 over and 10 this way to get C prime. Then I'll connect my dots. There it is. Did you realize what we had that was different about the original image and the one that we reflected? You notice? Well, see how it's flipped? How the A was over here, now it's over here, and how the C. So our image then is reflected.
This is Miss Hill, and your learning goal today is I can translate points and reflect them on a coordinate plane.